So in this problem, we have to show that f of z equal to z e raised to z is analytic, and we have to find out its derivative. Now guys, how to show that given function f of z as analytic or not? So we know that we have Cauchy-Riemann equations with us. So by using Cauchy-Riemann equations, we can prove that the Cauchy-Riemann equations are satisfied, and if the equations are satisfied, then we can say yes, f of z is analytic. Now here f of z is given in terms of z, so where z is a complex number. So now we have a choice. We can represent this z as x plus iy, that is in Cartesian form of complex number, or you may represent z as r e raised to I theta, that is exponential form of a complex number. So when we represent it in a form x plus iy, it is a Cartesian form. Hence at that time we have to use Cauchy-Riemann equation in Cartesian coordinates. And if we are taking z as r e raised to I theta, so at that time we have to consider the Cauchy-Riemann equations in polar coordinates, since we have r and theta in z. So here to solve it, I am going to use the Cartesian coordinates. So here let's start with f of z. So f of z is equal to z. So z is nothing but x plus iy e raised to z, again x plus iy. So I have represented z as a Cartesian form of a complex number, which is x plus iy. Now let's solve this. So here we will get x plus iy, here e raised to x into e raised to iy. Now by multiplying this with x, we will get x into e raised to x into e raised to iy plus iy into e raised to x into e raised to iy. Now what is value of e raised to iy? So we know that the value of e raised to I theta is equal to cos theta plus I sin theta. So this is nothing but the polar form of a complex number. So we usually say that there are three forms of complex number. One of them is x plus iy, which is Cartesian form. Then this cos theta plus I sin theta, by assuming the r, that is the modulus, as 1. So that is the polar form, or I will say here r into cos theta plus I sin theta. This is the polar form, and r e raised to I theta. So this is the exponential form. So what I am doing, friends, that I am representing this e raised to I theta as cos theta plus I sin theta. So this is one of the standard identity. Now here I got e raised to iy term. So I can say that theta is y. So I will get cos y plus I sin y. So here I will say it is equal to x e raised to x in bracket cos of y plus I sin y. Here I will say plus I y e raised to x in bracket cos of y plus I sin of y. Now by multiplying the bracket with the term x e raised to x, we will get x e raised to x cos y plus I x e raised to x into sin y. And now multiplying the second bracket with iy e raised to x, we will get iy e raised to x cos y, and I into I square, which is minus 1, so minus y e raised to x into sin y. Now guys, here we got 4 terms. Out of that, first term and the last term is real, so I'll take it inside a bracket. So x e raised to x cos y minus y e raised to x sin y plus I, here we will get x e raised to x sin y plus y e raised to x cos y. So I have taken the imaginary terms together. Now guys, why are we doing this? So the reason is we want to separate the real and imaginary part from the given function. so that we can compare it with f of z equal to u plus iv, where the real part will be called as u and the imaginary part will be called as v. And from u and v, we can get the Cauchy-Riemann equations in Cartesian coordinates. So now, here by separating this real and imaginary part, we got the values of u and v. So I'll say u is equal to this first bracket and v is equal to second bracket. So we will get now, after this, we have to prove the Cauchy-Riemann equations from u and v. So what is Cauchy-Riemann equation? So the first equation is dou u by dou x is equal to dou v by dou y. So for that, we need to find out dou u by dou x and dou v by dou y. So here I'll find out the value of dou u by dou x first. Now dou u by dou x is nothing but partial differentiation of u with respect to x. And friends, you must be knowing that whenever we differentiate any function partially, that time we just consider a single variable. So here if I am differentiating u with respect to x partially, so x will be the variable, or I'll consider x as variable in u, whereas y will be treated as constant. So in u we have variable as x and y. Out of that, x is the variable of differentiation, whereas y is constant. So since y is constant, I can take cos y outside. So just I have to differentiate x e raised to x. So by the product rule of derivative, you will get x, then derivative of e raised to x as e raised to x, plus e raised to x as it is, and derivative of x is 1. So you can also call it as UV rule. So this is the derivative. Next, in the second term, again y is constant. So here I can say minus y and sin y outside, and the derivative of e raised to x is again e raised to x. So we got this value for dou u by dou x. Now what is dou u by dou y? So here we have to differentiate u with respect to y partially by treating x as constant. So if x is constant, so x e raised to x, both are constant, where these are the function of x. Now for cos y, if I'll differentiate it with respect to y, we will get minus sin y. So minus here and sin of y. Next, in the second term, I can take minus e raised to x outside since it is constant, and for y into sin y, we will use the product rule of derivative. So this is nothing but y as it is. The derivative of sin y is cos of y. Next, plus sin of y as it is, and the derivative of y is 1. So this is the value of dou u by dou y. Now friends, let's expand this value. So here we will get cos y into bracket. So x e raised to x into cos y plus e raised to x into cos y minus y sin y e raised to x. Similarly, by expanding this, we will get, here I'll write, so minus x e raised to x sin y, next minus e raised to x y cos y, and this will become minus e raised to x sin of y. So we got the value for dou u by dou x and dou u by dou y. Now let's differentiate v with respect to x and y. So we will get dou v by dou x as, here sin y constant, so outside the derivative of x e raised to x by product rule will be x as it is, derivative of e raised to x is e raised to x, plus e raised to x as it is, and derivative of x is 1. Next, plus, now y and cos y are constant because I am differentiating with respect to x partially. So y outside, cos y outside, and the derivative of e raised to x is e raised to x. So here by expanding, we will get x e raised to x into sin y plus e raised to x sin y and here plus e raised to x y cos y. So we got these three terms. Now let's find out dou v by dou y. So we'll differentiate v with respect to y partially. So x is constant, e raised to x is constant, and derivative of sin y is cos y. Next, here e raised to x constant, take it outside, and we'll use the product rule for y into cos y. So y as it is, the derivative of cos y is minus sin y plus cos y as it is, and the derivative of y with respect to y is 1. So by multiplying the bracket with e raised to x and adding this term, we will get x e raised to x cos y, here minus e raised to x y sin y, and the last term will be plus e raised to x cos of y. Now guys, we got all the four terms. Now let's observe two terms. So if you will see dou u by dou x and dou v by dou y. So the first term of dou u by dou x is x e raised to x cos y, which is present here, yes, as it is. Next, plus e raised to x cos y, which is also present here, and the last term is minus y sin y e raised to x, and here we have minus y sin y e raised to x, it is also present. So can I say that dou u by dou x is equal to dou v by dou y? Yes, that's absolutely right. So here I'll say therefore dou u by dou x is equal to dou v by dou y. Now let's see the other two equations. So here we have dou u by dou y and dou v by dou x. So here we have a term minus x e raised to x sin y. Here we have x e raised to x sin y. So guys, just observe the difference. So both terms are same but opposite in sign. One is positive, one is negative. Next, we have e raised to x y cos y, which is negative, and here we have e raised to x y cos y, which is positive. And the last one, e raised to x sin y positive and e raised to x sin y negative. So it means, can I say all three functions are repeated in dou u by dou y with negative sign? Yes. So I can say that this dou v by dou x is equal to minus dou u by dou y. And guys, if you'll see, then these two are nothing but the Cauchy-Riemann equations in Cartesian coordinates. So here I can say therefore the Cauchy-Riemann equations, or we can say it as CR equations, are satisfied, and therefore we can say that f of z, which was given as z e raised to z, is analytic, since Cauchy-Riemann equations are satisfied. Now if we'll see the problem, then we have to show that it is analytic, and the next question was find its derivative. So here, to get the derivative, we'll say differentiating that function f of z with respect to z. So therefore we will get f dash of z equal to, now z e raised to z. So by differentiating it, you will get by UV rule z as it is. The derivative of e raised to z is e raised to z plus e raised to z as it is, and the derivative of z is 1. So here I can take e raised to z outside, in bracket z plus 1, and guys, this is nothing but the derivative of that analytic function. So here we got the given function as analytic and we got the derivative of the function. Thank you.